Hello guys, welcome to Science Feast. This is part 2 of Momentum and Impulse, a series that I'm having on YouTube. The measurements that I want to focus on, so we know that momentum is equal to m times v, with the mass being our so the mass will be measured in kgs. The v velocity will be measured in meters per second. So then that makes momentum being equal to kg meters per second. So this is the measurement for momentum. For force, we know it's newtons. So force, that will be newtons. Impulse, remember I said impulse can also be the same as F net multiplied by delta t, which equates to change in momentum, I mean. So then this is equal to change in momentum. So we said impulse can also be equal to change in momentum, but the measure for impulse will be F net, which is newtons per newton second. So it's newton seconds. Force experienced at a certain time. Okay. Another one will be acceleration, which is meters per second. So -2, so that will be per second. I think these are all the measurements that I wanted to discuss with you guys. So just make sure that you familiarize yourselves with these measurements and you don't mix them up. Okay, so now moving on to the principle of conservation of momentum. So what this actually means is that the momentum is conserved, meaning that whatever happens before the collision and after the collision, the momentum remains the same. So if we have an object that collides with something, the momentum that it had before collision, so this is before, and then it collides, it's gonna have the same momentum afterwards. Okay, so this same object that collided with this, after the collision, the momentum of that same object is the same before and after. That is conservation of momentum. So we will see how this plays a major role in the next thing that I'm going to discuss. So remember, we would say P initial will be the same as P final, or you can say P before will be the same as P after. So that's the principle of conservation of momentum. The momentum before collision is the same as the momentum after. So yeah, that's not the definition you would give in the test or the exam. So I know you guys can sort of the definition, but in basic words, it just means that the momentum is conserved before and after. So like I mentioned, we are going to work a lot more around this principle. So what actually happens now, let's say we have two objects. So this is two objects, they collide and separate afterwards. Okay, you can have two joined together before collision, they collide and then they become separate. Then you can have two separate, they collide, they become a unit afterwards. Or we can have one and another one here, they collide, and then this would be stationary, so it was standing still, and then now you have both moving separately. Or you can have one stationary, collision appears, after collision then you have two together. So these are scenarios that you can come across, but I really don't want you to memorize these things, okay? So all you have to do is to understand what you're doing. So if this is A, this is B, this is A, this is B, so this is before, no, so this will be after collision, and this will be before collision, okay? Now I'm going to show you the equations that you use when you are solving these kind of problems, okay? But I don't want you to memorize all of these things, okay? These are the things that can possibly happen or possibly okay, but all that you need to do is to understand the wording in that question or the diagram that is being illustrated to you, and you put that to physics. Simple physics, don't complicate things. If you actually try to memorize all these situations, and because all of them, they will have different simplified equations, but you really don't have to do that. So because then you have to remember 1 2 3 4 5 different equations, or even more. So I'm going to show you the simple way, the basic. Stick to the basic, don't ever overcomplicate things. Every physical science problem will be different, and you need to approach it accordingly, and not to something that you have memorized or anything like that. Just understand the wording in the diagram. So I'm going to start with the most basic one, okay? So what actually happens is you have your momentum before, so this will have its own momentum, this will have its own momentum as well, this its own, that its own, okay? So then we have P of A, then you can write before, that's the B, plus P of B, then you write B. Can you see how neat this is? And it's actually easy to follow. Then here you write P for momentum, A for the object A, after for the after collision, and then you do the same here, P B for the object, A for the after, okay? So this is the momentum before of the system, because now it becomes a system, it's two things coming into collision, and then whatever happens. And this is the total momentum afterwards. Total momentum before, total momentum afterwards, they have to be equal. So now I can go on and put my equal sign there, okay? This I know it's M times V, okay? Now I still have to keep in mind that it's A, so then I can write my A there, and B plus M times V of B, then I write my B, equal to M times V of my A, then I write my A, plus M times V of B, then I write my A here, okay? So you really want to minimize the things going on there. You don't want to have a lot of values and stuff, but this is the basic equation you should start with whenever you get a momentum conservation of momentum question. Start with this equation. I don't care how smart you are or how smart you think you are, start off with this equation. Okay, two objects before, two objects after. I don't care if they are connected or not connected. Okay, then you move on. If now you have to listen carefully, if the objects are connected before the collision, okay, let's think about it now. If we have object A connected with object B, what do they share in common? Okay, so let's say this is 3 kg and this is 4 kg. What they share in common is the velocity, because if you are moving as a unity, you will have the same velocity, or if you want to put it in more simple English, you will have the same speed. Okay, A and B will have the same speed, but they do not have the same mass. Okay, so if they have the same speed, I can now go on and factor out the velocity. Then I can have the mass of object A before plus the mass of object B before. And now I can write my V there. V before, because they are a unit, I can factor out their velocity because the velocity will be the same, and then multiply that by the total mass of object A and mass of object B, because these two will not have the same mass. And then if they become separate afterwards, I leave it as that is. Okay, so I'll just put apostrophes here just to say this is the same as that. Does that make sense? It should. Start with this, and then according to what you are observing, according to what you have, then you combine. Okay, remember, we are doing this step to make things easier. We don't want everything to be clustered, because then you can actually have a lot of things. Imagine having to put this value here and there, but it's actually the same. You can just as well factor out the velocity. Okay, so that is one situation. If it happens that it was separate before and then afterwards it was joined. Okay, so once again, can you see what I'm doing? I'm not erasing this out because this is the general one. Okay, now the second scenario is that we have these two. I'm just doing this to illustrate. I know you guys can by now do any of these things. Okay, let's now have them as a unit afterwards. Once again, we factor out, because it's a unit, it's going to move with the same velocity. We factor out velocity, so then VA for V after. The mass of object A after plus the mass of object B after. Okay, this remains the same, m dot V A plus m dot V B before, as simple as that. Okay, so what I really want you guys to take from this is that you have to start with that, with this equation. Always start with that equation, and then based on the situation or the diagram that you are given, you can now move on and say, okay, I'll factor out things and get things off the way so that I can easily do the calculation. Okay, in part 3 I will do the calculations, but I just want to get off all these basic stuff out of the way. So now we've discussed all of those equations. What I want to focus on now is the direction. Okay, direction is really important. So when you are working with velocity, right, you have to specify your directions. Okay, so if you have object A, object B moving in the same direction, and then when they collide, you have now object A moving in the backward direction and object B moving in the forward direction. You need to specify your velocity. So you can say V to the right is equal to positive, and then V to the left is equals to negative. So then here you would have, remember they are separate, all of them before and after they are separate. So I will have mv for this object, let's say A before, plus mv for this object, let's say B before, is equals to mv A after plus mv A after. No, this is B after. Okay, so now you move on to the signs. You know how your equation is going to be. This is fortunately the general equation, so I don't have to really worry about anything. But now, since I said right is positive, this V will remain positive because we are going to the right here. This also will remain positive because we are going to the right. Let me just write B, A, B there. Okay, this one, because it's going to the left, is going to be negative. So now I can just do that and say M minus V. Okay, plus mv, this is going to the right, so it remains positive. I just leave it like that. Okay, so then when you're calculating this velocity, you know that this is negative. So if they asked you to calculate the velocity here, and you put it as it is, like with the negative v there, when you have done all your calculations and now you're looking for that v, you will have minus v being equal to something here. Let's just say some x value, right? So then you can say v, because you don't really want a negative quantity, so then you say v will be some x divided by -1. So I divide by -1 to change this to v. So then v will be negative something, because anything divided by negative will be, so if this is positive and then you divide it by negative, it will give me negative something. Okay, some x value. But remember what I said, when it's negative, it's going to the left. So then when you give your answer, you don't give -5 meters per second. No, you give 5 meters per second to the left. Okay, so that's really important. But yeah, that's about it with the signs. Now we are going to move on to elastic collisions and inelastic collisions. Okay, so these two are really important. When it's elastic, it means the kinetic energy before is the same as the kinetic energy after. So this would be before, this would be after. But remember, this is momentum, right? So why not just say half of momentum so instead of writing all of that, you can just say, since this is equal to momentum, you can just say half of momentum, the total momentum before or after, multiply by the velocity before. Okay, so this is the total kinetic energy. It's not just a kinetic energy for one object. So let me just show you how it actually works. So let's say now we have two objects, object 1 object 2 being equal to object 1, object 2. Okay, this is after collision A, B, A, B. Okay, so this will have its own momentum, P, A, P, B, before, P, A, after, P, B, after. Okay, so now for you to prove if it's elastic or inelastic, so elastic, kinetic energy is conserved, which means kinetic energy before will be equals to kinetic energy after, right? So for this inelastic, it means that your kinetic energy after is not equal to the kinetic energy before. Okay, so now when you look at this, remember we add these and we equate them, right? So for kinetic energy, we literally do the same thing. Kinetic energy of A before plus kinetic energy of B before. But we don't equate it because we are trying to test if it's elastic or inelastic. We only equate at the end. So what you do it separately. So this will be kinetic, no, sorry, I meant to write kinetic energy there. So this will be kinetic energy total of before. Yeah? Then you do a separate equation, kinetic energy for A after plus kinetic energy for B after. Then you get kinetic energy total for after. Then afterwards, now you can say kinetic energy, if these two are equal, then you can say kinetic energy of total before is equal to kinetic energy of total after. Only after finding out if these two are equal. If they are not, then you can say they are not equal, therefore it's inelastic. If they are equal, then you say equal, then it's elastic. Okay, now let's say you have already calculated the momentum. So let's say you know the momentum for this individual, so you already know the momentum of this is 5. You also know this is 6. You also know this is, because the rest of conserved, so I can have now 3 plus 8, because 3 plus 8 is 11. 5 plus 6 is also 11. Okay, so let's say these are the given momentums already. You already know them, and you're also given the velocities for this and this and this and that. Okay, instead of writing half mv squared, you can now write, like I showed you, half of momentum times velocity. So then you can just take your 5 velocity and your given momentum already, then you can just put in here 5, and then your velocity you can put also, since it will be given to you. Then you do the same for this object, which is half of momentum, right, of momentum of B, then you multiply by the velocity of that B. Then you do the same with the final as well. You have to be careful and not not put the total momentum. So you cannot do this and put the momentum of 5 plus 6, because their velocity is not the same. Okay, but if this was a united object, then you could say, okay, their velocity is the same, so I can combine their momentum and just write, multiply that by v. But if they are separate and they have different if they are separate and they have different velocity, you cannot combine and put this p as total. So this p is for individual objects, not collective, unless if the objects are a unit. Okay, that's the only exception. Yeah, so what I'm going to do in the next video, I'm going to do some calculations, then you can see how I actually approach these questions. I'll do the question from the recent final exam that it was. So that's about it for me. Keep working hard and all the best with your studies. Don't forget to like, comment, share and subscribe. Otherwise, till then.